Greetings, greetings. All right, so yeah, we'll go ahead and start. Welcome everybody. It's the 2nd of September, and this is Open Research Institute's FPGA Meetup. And what we do is we talk about what we have done and what we have planned to do. If we have any resources that we need that ORI can help with, and if we have any roadblocks. So let's just get right started with our roundtable on what we've been up to. And I will hand the floor over to Aaron.
Hi, y'all. I've been really busy with work last couple month or so, but I'm getting back into it. And so I'm basically where I left off, and where I left off was working on porting the DVB-S2 encoder onto another platform outside of the Pluto, using OpenCPI. And I ran into VHDL 2008 compatibility issue with OpenCPI that I think I have a solution for that I'm start looking into, that will basically implement the encoder inside a block design and have that synthesized, and then use that synthesized netlist to integrate it into OpenCPI, which then I can move forward. The long-term solution would be fixing OpenCPI such that it can compile 2000 VHDL 2008. But I think this would get us to have something to play around with quicker. So I've been following along with these videos. So impressed with all the work that's going on with the interlocutor and all the other stuff, and excited about getting back into it. And that's it for
Awesome.
me.
Right on. Wow, that's a lot. And remarkable confluence here because the version of VHDL that we were specifying, um, which you're talking about that here with being able to compile VHDL 2008 was a problem today. So we had we had to make absolutely sure that in the test benches for the for MSK, for the Pluto MSK, that we were calling out 2008 because that's what the source code uses, and the default in Vivado was not that. So several of the syntax errors that we had over the past day or so were related to that exact problem. So it's happening to us too. And in our case, it's just a set properties and in the Teckle script that calls up the project and marches through and orders up the various test benches. So not too bad. The current hang up appears to be, I think I botched the port mapping for to kind of bring in the whole MSK modem. So I got some names wrong, and I'm marching through that. But no doubt that the version skew will probably crop up yet again for us, maybe a little bit later in the process later today. So yeah, we're very excited about your work. And for those who would like to learn more about OpenCPI, it's opencpi.org. So please go check it out. It's really very powerful. And Aaron's fantastic. He's one of the leads of this project. And yeah, we're looking forward to leveraging this as much as possible to try to get our work out there on as many different platforms as possible. And then I guess I'll turn it over to Paul. You've had some adventures and some results here over the past week.
Yeah, um, we've been chasing down these gaps in transmission uh, when we're streaming data to the MSK modulator. And for a while there, I really wanted to blame the USB Ethernet interface, and because it looked like it was sometimes slow for no good reason. Uh, I wanted to prove that to myself, so I divided up the USB Ethernet from everything else downstream of it. And lo and behold, under those circumstances, the USB Ethernet was working just fine and sending the frames like clockwork, 40 milliseconds each. So I turned my attention elsewhere, downstream, and well, I don't go through all the gyrations. There have been quite a few gyrations. Um, we still don't really know what's going on. There's got to be some handshaking uh, going on between the modulator and the DMA transfer uh, initiated by IIO from inside Dialogus, and trying to track that down. That one thing that became pretty clear in a discussion with Matthew last night is that, and we knew this, but hadn't really considered it to be super important. We were sending the wrong number of bytes per frame. We're sending the raw data, and the modulator is really expecting the data that's already been scrambled and encoded. So it's and has a frame sync at the front, so it's a little bit more than twice as big as what we've been sending. And you would think that this would result in a frame underrun every frame because we're sending uh, under half the data that's expected. And maybe it is, and maybe I just don't have enough observation resolution to see it. I've been relying on the waterfall from the Rigol spectrum analyzer, and it runs about uh, 30 lines of pixels per second, which means just a little bit faster than the frame rate, which is 25 per second. So anything that's happening sub frame rate is going to be hard to see or impossible to see on that display. So time to bite the bullet and modify the software so that it actually sends the right number uh, of bytes to the modulator. Um, I've done that almost. I was hoping to get it done and tested before this meeting, but uh, apparently I'm not that fast at coding anymore, so it's taking me a while. Um, Getting some seg faults, and they'll go away soon. I'll probably have it done, maybe even have it done before the end of the meeting if I keep coding while listening. But I don't know what's going to happen. Um, if I keep the pipeline full, then it ought to be perfectly happy. But it should have been pretty happy anyway. So it'll be really interesting to see what happens next. And hopefully it won't be too confusing. I think that's the summary.
Wow. Okay. Yeah, lots going on. So thank you so much for all of that work. The yeah the end-to-end demo. So that's kind of our always our goal for any sort of communication system that we work on here is that it works end to end over the air. And for our uplink for the Opulent Voice, which is either can be an uplink for a GeoHeo or it can be a terrestrial protocol. Uh, the way that we're trying to do a prototype here is to construct the frames, and we're using Python, so construct them and then send them as a over an internet link. So if you, as long as you have an IP address, we can deliver sort of these baseband data frames to you, and you being a modem. In this case, the modem is a Pluto SDR. And when we put these two things together, which have been demonstrated very successfully separately, then we discovered this weird timing gap issue. So over the past week or two, we've been trying to fix that. And towards that effort, in parallel with all of the things that everybody else is doing, what I've done is to set up some test benches for the modem itself. So we initially suspected that maybe the way that we're using the transmitter buffer, so it's a transmitter buffer push out to DMA, uses AXI to get it into the modem and all that, that it was on the processor side or maybe the Linux side or the USB driver was messing up. And Paul, I think, pretty definitively eliminated that as a primary suspect. It still could be something we've got set up, still could be wrong, but I wanted to exonerate the HDL because it's been working really well for months, and especially running the internal PRBS code. The waveforms that it puts out are lovely. Everything's working pretty good. I know that Matthew has identified there is still a minor bug in, I believe, the modulator, but it doesn't really stop it from working in general. And so it was a little bit confusing to see all these very weird gaps. And when I say gaps, like delays, then if you push to talk in the lab and you talk over the air, then you let up on PTT and the Pluto transmitter, Pluto modem still keeps going for many, many seconds. So this is a pretty significant problem. And so what I did was wrote some test benches. The first of the 3 test benches, all it does is goes from the internal PRBS. So, we're just going to give you a stream of bits and we're going to use the same mechanisms. But instead of giving you the PRBS signal internally, instead of generating it internally, we're going to just move the source outside so that it comes in essentially over USB. So it's just a stream, no frames or anything like that. The second test bench is putting together frames, and we're going to adjust it to where it's actually matched up with the proper bit rate, hard-coded bit rate in the modulator. Like Paul mentioned, we've been shortchanging because we haven't been put in the FEC or the blanking or anything like the whitening or scrambling, anything like that. So we're not really delivering the entire frame. We're delivering just the data. And yes, you can get away with that with interlocutor and over the internet, but like the modem was designed for all of the FEC and all of that stuff to be in there, so it's expecting more bits. Okay, so fair enough. We're going to try that. That'll be the second one. The third test bench actually goes in and sort of brings out any sort of delays in between the submodules. So I didn't go like inside the submodules, all of the different Lego bricks that we're using to make the modem, but what it does is kind of like highlights and forces the interfaces between the submodules to report how many cycles they're consuming. And I'm hoping that this will produce a table where you can just look at it and you go, oh, okay, so you can see that this interface is not performing well, if that happens to be the underlying problem. What I'd like to see is that the HDL is exonerated, that it's not the problem is not coming from HDL. But then we have even more of a mystery because it does not appear to be coming from the processor side either. So so the plot will thicken by quite a bit, But so I set it up sort of with a test driven design sort of mentality, like, okay, let's come up with a way that would exonerate the HDL, and it should clearly show that. So right now, work through a number of bugs, like, just trying to get everything instantiated correctly in the test bench, figuring out that, yes, you need to explicitly specify VHDL 2008 because there's some choices that are made in the source code that with the default from Vivado, it does not default to 2008. And that took a couple hours to figure out. And, just getting through all of the things. Right now, there's a port mapping issue, didn't quite do that right. So once we get to the point where we can launch the code, we should have some results that will point us in the right direction for this end-to-end demo goal. So that's what we've been doing. And that's what we've got here. We have a number of opportunities to show off the end-to-end stuff working coming up. We'll be able to talk about this in just a couple of weeks in Germany, and then in October at Pacificon. So be really great to get some good work done and either show it live with actual circuits like we did at DEF CON, or a poster, or some sort of imagery or report. All right, so that concludes all I've got. Basically, it's lots of hard work and hard work joyfully done, because it's challenging, and yes, some of the stuff can be frustrating, but it's really good stuff. So looking forward to the rest of today. And that's it for me. And I see Rick is here. Hi, Rick. I thought you were going to be on the road. So if you want to tell us what's going on with DSES and let us know how anything that you got with the drift scan project, then that'd be great. Oh, I think you're still muted.
Hello, hello. That works? I've never used this for Zoom before. I am in the building at Haswell, sitting underneath the 60-foot dish, and I have run out a whole bunch of new microwave parts, splitters and attenuators and gain block and things. And I'm trying to revise the hardware because when I got home last time, I discovered that the various blocks in GNU Radio that we're using, written by a variety of different people, did not allow me to adjust the gains in these various blocks. Even though some of them had gain parameters, they didn't work.
Right.
And because of that, I had the first time we set it up, the gain was so low that we were always down in the noise floor. The second time I set it up, I had the gain so that our display in GNU Radio showed us well above the noise floor, perhaps too far because I had too large a gain block, a 30 dB gain block down here, and of course we have a 30 dB gain preamp up at the feed, which is basically sets the noise figure.
Yeah.
But the 30 dB gain block down here brought us up well above the noise, and then we have a signal generator that we can send a signal all the way back up and inject it into the feed so that we can then see how things are going. And I determined that we had about 30 dB before we hit blocking on the receiver. So I thought that'd be okay. Well, it wasn't okay because all these blocks in the GNU radio are all fixed gain and they're not the right fixed gains. So before I start digging in and modifying other people's code that I don't know, don't understand yet, I decided to bring a huge supply of various attenuators, and because I have new gain blocks on order, but they're not here yet. I also replaced the splitter, which was sort of a no-name 3 dB splitter that we weren't sure of its characteristics. I bought a bunch of mini circuit splitters that are the right splitters, and then I replaced all the 5-foot cables with 1-foot cables, so it's nice and neat. And now I'm going to record data for short durations today and play it back and keep doing that until I get the attenuation such that I'm not saturating any of the blocks.
Yeah.
Hopes that will temporarily solve the problem while I try to figure out why I can't adjust the gain remotely from home. It's a 140-mile one-way drive out here to put in a few attenuators and make cabling a little neater.
Yeah.
The good news is in the background we have two gentlemen who are working on another really interesting science experiment called eCalypso. And they're trying to get the controller board that we designed to steer the antenna so it tracks the sun. So we're recording noise from the sun with that antenna out back.
Right on.
And we have plenty of other experiments out here, and
Yeah.
I'd like to get the
Well-
30-foot dish put back up, but we
Well,
need more volunteers.
how about a quick tour then? I don't think that we've ever actually seen the inside except for during the last Eve. There was a camera there for Eve in March, I think, but we didn't see anything walking around. So if you
I'll
give us
give
a
you
quick
what
tour, that'd be fantastic.
I'll give you what I can.
Okay.
Because I'm not using my phone, I'm using my laptop, and it's hardwired to the internet. So it's not Wi-Fi. We don't like Wi-Fi out here.
Yeah, I know. It's a little.
This is the control room. Back there, what you see there is what will be the new ham radio station for EME. And if I can make this lighter long enough, I can turn all the way around. This is the science rack and some of the equipment I'm working on. And this science rack has a large table and then another rack of equipment, which is these are our signal generator, spectrum analyzer, and wide capable radio. And we use those for calibrating the system, for looking for RFI signals and so forth. And then if I spin this all the way around, let's see, it's somewhere here. Hey, Ray, turn around. You're on camera.
Oh,
Say hello to Michelle.
oh yeah.
Hi, Ray.
Hi there.
Ray's working on eCalypso today, while I'm working on drift scan.
Outstanding.
Way over there,
Ed.
we have Ed. Say hi, Ed.
Hi.
Very
So-
good. Hi there.
And this is just one room of the building. It's much bigger. We have a classroom, a kitchen, a bathroom. And you can't really see much of the dish out the window, but I can't see what I'm showing you. Let's see. Out the window, it's such a bright day. We have a pedestal and a what looks like a tower with ladders in it. That's how you climb up to the feed point to change the feeds. So typical lab,
Yeah, very good. Outstanding.
and we have just enough equipment here to do the essential stuff. And then we have, Ray has a lab and I have a lab at home that's much better equipped for designing things. So you guys, you and Paul especially gotta get out here and see the place for real. It's 18 acres or so in the middle of flat farmland, as flat as far as you can see. And we drove up today, and last week they'd had a big rainstorm, so one of the fields had gone, all the dirt had gone across the road into the other fields. So driving in here, you couldn't see the road from the fields. So today we drive in and it looks like they've had a road grader out there and they fixed the road, but they plowed all the dirt in front of our driveway. So it's very helpful to have four-wheel drive out here at times.
Yeah. No, it's yeah. I think probably something very similar happens with snow.
Yes,
Snowplows
oh my God.
they like to cut off the end of your driveway if you ever lived with a lot of snow.
Well, we get plenty of that too.
Yeah.
Of course, we have See, we have more microwave devices showing up. They just magically show up in case we need to adjust the attenuation today.
Oh, very good.
But anyway, yeah, all the roads here have signs on them that says we do not plow after 7 p.m. or before 7 a.m.
Right. That's right.
Well, oh, here, what are you showing her? Oh,
Aha, very good. I like
thought
it.
that's what it was. Okay. And turn speed limit sign.
I like the speed limit sign. Where is that? That's in there somewhere,
Yeah.
right?
Yeah, we got a speed limit sign here.
It's not just a good idea, it's a law.
We,
Excellent.
we have all kinds of cool stuff out here.
Very good. And there's I know there's an open house coming up, isn't there?
Well, there's a picnic at my house this Saturday, and then the open house is, when is the open house? The end of the month?
Yeah, it's
Somewhere.
like late September, right?
Yeah, I think so.
Very good.
So, yeah, I wasn't expecting to sign on here today, but I said, well, I'll bet she would like it if I tried at least.
No, that's really great. Getting a tour is fantastic. And yeah, I think no, it's going to be, it's really, really nice to be able to see the interior and all the things that are going on. So thank you so much for doing that.
Well, it's my pleasure, and I've got plenty to do today, but it's all fun work. I
Yes.
don't have any grunt work today. No
Hey, very
mowing of lawns or any of that stuff.
That's right. We know about grunt work too. It's awesome. Well, I see Matthew has joined us, so I'll turn the floor over to him and hear what he's got and any advice that he might have for all the things that we've been doing.
Oh, thank you. Sorry, I was a little late joining. I got over dealing with drainage issues at the new place. We have a nice big slope driveway, and when the torrential rains come, it floods our area in the front and creates problems. So trying to figure stuff out. Anyway, we yeah, I just been trying to keep up a little bit with the discussion in Slack regarding the VHDL code and the test benches and whatnot. So I just offered some thoughts as I've had them or seen what's happening. But if there's anything in particular that we need to go over, I'm happy to help, of course. I didn't have any other particular updates this week. So I'm just trying to help out where I can as stuff comes up.
Yeah, thank you so much. Yeah, sure. Most of the errors, at least from my end, are completely self-inflicted. Right now, it's I didn't quite get the port map right on pulling in the modem to the test bench, but at least we're getting now getting that far. And then I think I told everybody else, but as you know, the first test bench is just to duplicate the PRBS style exercise of the modem, but bring in input over, from external sources. So just trying to take a very incremental step forward. And the second test bench will be actually to go to frames, and then we're going to take all of the things we've discussed over the past just day or so. Because yeah, we're underfeeding it by quite a few bits. We're only really giving it half what it needs. So I'm going to go ahead and adjust. Like here's the whole frame, rather than just giving it what we've been using for interlocutor. And then the final test bench actually goes in and measures timing between the submodules, just to kind of bring all of that out, just in case there's something in the HDL that's doing something weird. The whole goal of this set of test benches, though, was to exonerate the HDL, to kind of like show that it's not the source of the issues, or to show it. Either way, if it's not in there somewhere, then it's a kind of a mystery. But we like those sorts of things, and we'll just dig in a little harder. So I think that it will start showing some results by the end of today. But as a raging optimist, that's that's it.
Was this like a new VHDL test bench that or what?
Mm-hmm. Yeah, it's a VHDL test bench. This is pretty straightforward, just within XSIM. So I'm just setting up a test bench and writing VHDL to exercise the modem. in a way that is as close as possible to the situation that it finds itself in inside with Dialogus. So setting it up the exact same way that it's set up in the code. And if it duplicates these weird delays, then we have a clue. And if it behaves perfectly fine, like it behaves with internal, the PRBS, then we have another clue. So that's the kind of the goal is to press things forward and to exercise it. And I guess also in another way, if I can set up some test benches like this, then I'm in a better place to be able to kind of say, uh, you know, for either interlocutor or dialogus, like, okay, so now we are able to have some A/B comparisons over time. So I can set up a long sort of transmission. I'd start constructing actual like short over the air transmissions from a test bench. And then we can start looking at like, oh, we want, because I know we want FEC, and we do have penciled in a convolutional code for the body and a Golang code for the header. And those are decent choices, but you brought up spinal codes a bit ago. And there are also a lot of other really interesting forward error correction codes. And so if we have a environment where we can start making some simulation comparisons, then I think that'll put us in a good place. And then we can.
I was going to suggest that VHDL is a really crummy test bench language. What I've been using is CocoaTB, which is Python, which is really nice to drive the HDL directly with Python. So, I don't know, it's something you might want to consider if that was something that worked for you. That I think the test bench I've done now, it has some classes and stuff that's really easy to configure the modem, and then you can just create new sources, ways to drive and receive data. So it kind of abstracts the modem, into a, just something you send data to and receive data from. And, so it makes it really nice to have the Python environments, and you can use Matplotlib for, generating graphs directly, kind of, you can even do it live, but I mean, at least for generating from the data directly from Python from the test bench. So I don't know, it's just, I found it really powerful. So, I mean, it sounds like some of the kind of stuff you're doing, it might be really nice over a VHDL test bench, but whatever you think is working the best. I just was a thought.
Yes, as soon as I'm smart enough, then I will advance to to that. So for right now, if I can get it fully working in using a pure VHDL test bench, and then like, okay, I've got all that, and then I think that taking the next step and using CocoaTB will be a whole lot easier. So it's just my shortcomings. I'm just trying to come up through from as simple as possible, and everything is inside Vivado, and then add things, add extra features that are absolutely useful. So your advice will be taken. So it's just me going through a learning curve and making sure I'm very secure and know what I'm doing with ordering the design around. But everything will be published, and I'll show all the incremental progress. So definitely we'll move in that direction based on your advice.
Sounds good. Yeah, anything I can do to help out on that, please let me know.
Okay.
But like I said, I didn't have any other particular updates, just trying to help out as I can.
Yeah, no, thank you. It's very exciting. I think like Rick touched upon and Paula said, this is really neat work. And there's setbacks and there is roadblocks and things that are very confusing, and some of the tools problems that we've had over the past year have been frustrating. And there's some things that are totally under our control, and there's some things that are not. And sometimes figuring out what's really under your control and what's not is a little tricky. But overall, this is super amazing work. It's a really real privilege to be able to do it, and we'll just keep at it. And looking forward to the next week. So, Yeah, that's any last comments or questions? Anybody need anything before we close for the week? Cool. Okay. Well, thank you, everybody. And we'll report everything on Slack. And best wishes to Rick out there on the windblown steppes of Colorado, underneath the massive dish, setting up.
Surprisingly,
That.
it's a near perfect day. There's no wind,
Wow.
beautiful sunshine, no storm clouds today.
No snakes, no bugs.
Cross my fingers and it'll stay that way.
Yeah, yeah. Well, hey, take some pictures, and looking forward to hearing how it goes. And the whole gain chain thing, and not just because uh, something is in a GNU radio block doesn't mean that it actually does anything when you change it. That's something we've learned multiple times. So your
I'm
situation,
figuring that out, yes.
it's near and dear to our heart, especially setting the gain in like an SDR source. It turns out that it may look like it can range from 0 to 60 dB, but it's really only 3 steps, and it just rounds off to one of 3 steps. So we have found this out over time, and just do not be afraid to dig into the source code and make it do what you want. But it does take some sitting down and scouring.
Yes, well, we have already found one bug where there was supposed to be a divide by 2, and it divided by 2 every iteration.
Oh,
There was nothing left.
well, that will render. Yes, that will.
That'll do it.
That will do it. Wow. Well, good spotting.
Yeah, well,
Okay. Well, hey, take some photos, and best wishes to everybody out there, and see you all on Slack, and we'll do this again next week.
by the way, you are one of the very fortunate few who've ever received packets from Haswell over fiber optics.
Oh, that's right. That's right. This is new fiber optic link working.
Oh, it is.
Yes,
Yes.
very good.
I don't even have fiber at home yet. They last week I came home and I have to drive down Remington past Gun Road and Winchester to get to my house. You get the idea where I live, right? I'm driving down Remington, I get halfway down the street and here's the fiber optic crew burying cable. That would have been just fine with me, but the fact that the road was blocked off by the fire department was not fine. No matter how much they spray the road, they still hit something.
Yeah.
So I don't know what they hit, but they hit something. So that's slowing the project down.
Yeah.
But they're
never a dull moment
down.
with infrastructure, ever. Well, very good. And now these are special packets, so we'll make sure to tell everybody, what they're seeing. And good deal, Rick. All right, everybody. We'll see you next week. And see us on Slack, and reach out if you need anything. And best wishes for the rest of the day.